This is the lesson for section 1.1, evaluate expressions. And before we go too far into this lesson, I want to make sure we know what those two words mean, evaluate and expressions. Evaluate we'll talk about first here, and the question even says, what does evaluate mean? Here's the definition I would like you to write down. Again, anything in red, I also always want you to jot down your notes, so start by writing that down. Evaluate means substitute values in for variables and simplify as much as possible. I'm going to make it even simpler than that. If you look at the word evaluate, whenever you see this as directions for your problem, evaluate, you can see right in there, V-A-L-U, you can see the word almost like value right in there. That's what we're looking for when we evaluate an expression. We are looking for some specific value for the answer. So that value could be something like 11 or 55 or -8 or 2, but we're looking for a specific value when our problem is done. That's what it says, evaluate. So this example I have right here says evaluate this problem, and we'll get more into some of these problems very soon. It's actually the next section, order of operations problems, but notice how we have plus, subtraction, division. We have all these operations in this problem. We have to do them in a certain order, but if you were to find the answer to this problem, and maybe some of you already know it now or you can see it by looking at it, but the answer to this problem would be 12. Notice how it's just a specific value. Answer equals 12. That's what we're looking for when we evaluate a problem. We're looking for some final answer like 12. My next part here says, what's an expression then? So again, we talked about what evaluate means. So what is an expression then? We know what those two words are. An expression, and I have this as a definition here, but I'll have you write it down actually on the next page, so hold off on writing this in your notes for now. But an expression is a group of numbers, and it says here a group, a number, and variables that are tied together with operations. So if I look at the two examples here again, I say the problem might say something like evaluate. How do I know these are expressions? Well, they are just numbers like 15, 7, 4, 2, and they're tied together with operations that is telling you to execute those, like subtraction, like the parentheses around a number means multiplication, or like this division sign here. So remember, this is actually tells me this is an expression. It's just a bunch of numbers and then operations that tie those numbers together. Same thing if there's variables too. So this is x, 12, y, and 8. All those things I know, variables and numbers, tied together with operations. Here's addition, here's subtraction, here's division. So these are expressions. And one more keyword I want to throw in on this page. We talked about what evaluate means here at the top. We talked about what expressions are here in the middle. Also, I want you to know what an equation is. That will also be important here as we go on in algebra and the rest of your math career. What is an equation and how is it different? Well, an equation, we're going to look at this, it says it tells us that two expressions are equal. So expressions, remember, are just numbers and variables tied together with operations. If I look down at some of the examples I have down here, 9x, that's just a number and a variable tied together by multiplication. Okay, so that's an expression. And then I have a number just sitting over here by itself on the other side, 45. That also still is an expression. Well, it's tied together with this equal sign. It says that the left side's equal to the right side. An equation tells us that two expressions are equal. This one is equal to that one. So that's an equation. Okay. Same thing here. For just a second, I'm going to cross out the equals 11. Just almost pretend like it's not there. But if I look at this first part, 2x plus 5, that's just an expression. Expression sitting there by itself. But an equation says that two expressions are equal. So it says 2x plus 5 is equal to 11. So these are two expressions here. They're tied together by that equal sign. One more example of this. Look at these two expressions here at the very bottom. 4x plus 5, that's an expression. 10 minus 6x, that's also an expression. Those are just two expressions by themselves. An equation says that these two expressions would be equal to each other. So 4x plus 5 is equal to 10 minus 6x. So this is what makes it an equation, this equal sign that ties those two sides together. Now on this page here, I've kind of, just to more emphasize the difference between expressions and equations, I've made a table with bulleted points here of each one that I'd like you to write down. Again, anything in red, I want you to take down in your notes. So I want you to make a table like I've got up here, as I'll show you the rest of it here in 1 second. But expressions on one side, equations on the other, and all the things that I want you to know about those two things. So here are all my bulleted points, and they kind of line up with each other for expressions and equations to kind of list what are the differences between the two. And then also I do have examples down here. I think those would be also beneficial to put in your table so that you know So you have something to also look at and say, okay, these are expressions. Okay, or on this side you can say these are equations. So you know the difference between the two. You have something to look at. The top bullets there are just the definitions, kind of like I already mentioned on the previous page. So now you get a chance to copy those down. An expression is just numbers and variables tied together with operations. An equation, on the other side, tells us that two expressions are equal. It has that equal sign in it. Okay. Going back to expressions here. Expression, what we're looking to do, what happens with an expression? We try to find a value for it. We're going to evaluate. That's usually the directions that go along with an expression. We can't solve it, but we can find some kind of number, some kind of value for an answer. An equation is something we actually look to solve. And again, as we go on this year and we deal with more expressions and with more equations, you'll start to more see the difference. But for an expression, we're looking to find a value for the answer. Okay. For an equation, we're going to solve it and find out what that variable actually equals to. We can solve that. Here's the third bullet point, maybe the most important one in terms of looking at something and telling whether it's an expression, or whether it's an equation. Visually, an expression does not have an equal sign. Look down at these examples I have down here below. Okay, 14, 25 plus x, 5x minus 2y. Or 13 times 81. All those, none of them have an equal sign. So all these are just expressions. They're numbers and then variables and operations that tie them together, just like the definition says. Okay. The nice thing with equal signs, or I should say equations, is that they have an equal sign. So if I look at all my examples down here, I can see that 3x plus 2 equals 14. There's an equal sign right there. Okay. 9y equals 72. 2x plus 8 equals 7x minus 10. All those must be equations because visually they have that equal sign in. So that's the one nice thing about equations that I can just look at and say, oh, that's an equation. It has that equal sign right in the problem. And then our last one I've kind of emphasized a little bit already with expressions. With an expression, we're looking for some kind of result like 19 or 55 or 101 or -8. We're looking for some kind of value. That's going to be our answer. With an equation, our result is going to look like something we've solved, like x equals 19, or x equals 55, or x equals 101. We've found the answer. What does the variable equal to make that equation true? An equation, that's what we're looking for. Like for example, I'm just going to look at this middle one right here, 9y equals 72. To solve this equation, I'm looking for what number would y have to be, what could I plug in there to make that equation true? 9 times what would give me 72? Well, you could find or think about it that y would have to be 8. That's the number I would have to plug in there to get that solution. So this is what I have for my solution for that equation. Y equals 8. That's the number that will make that equation true. So for this particular assignment, though, we are going to concentrate more on the expressions. Again, it says evaluate expressions, so this is more what we're concentrating on. We'll worry about equations later, but I wanted to make sure we understand the difference between the two. But we're going to deal with equations. So the problem right here says evaluate. Again, that word we talked about, what are we looking for? We're looking for some kind of value for an answer. It says evaluate this problem right here, 25 plus x, when x equals 32. So they're telling us that x is equal to 32. That's the number that x stands for. So what we're going to do is we're going to take 32 and plug it right in for x. And I'm going to rewrite the problem. When you're doing the problems in your homework, here's what it should look like. This is the first step that I should see on your piece of paper. Okay, you've rewritten the problem, 25 plus 32. You've plugged the correct number in there, and now I'm just going to evaluate. 25 plus 32, what does that give me? That gives me 57. So there's my answer. If I'm looking for work on your assignment, this is at least what I should see, that line right there. I plugged the number in correctly, and then I went ahead and evaluated and found the right answer. Number 2, 85 minus k when k equals 41. We're going to evaluate that. Again, these are all under the title of evaluate, so that's what we're looking for, to find some kind of value like 57, just like that. Okay. 85 minus k, but they're telling me k equals 41. So I'm going to take 41 and just put it right in there. If you're showing the work on your homework, here's what it should look like. 85 minus 41, and then I'm going to go ahead and find the answer to that, and that's going to be my solution. So 85 minus 41 gives me 44. There's my answer. this last one down here, 90 divided by y, when y equals 15. So again, they're telling me y equals 15 in this particular problem. I want to evaluate it. I want to find the answer when y equals 15. I'm going to put 15 in there. So now this says 90 divided by 15. And 90 divided by 15 is 6. So there's my solution, my evaluation of that expression. I end up getting 6 for an answer. One more type of simple expression I didn't have on that previous page for an example, because I wanted to point it out right here, is what happens when I have an expression that looks kind of like this, where I have like 3x or 4y or 12z, 88k, all of these particular expressions. There is an operation in this expression, like I have the number 3 and I have the letter x, and they're right next to each other. So what does it mean to do with 3 and x? What we need to know and realize all throughout algebra, you're going to see this a lot. But when you see a number right next to a variable, that means you're going to take 3 times whatever x is. It means multiplication is the operation right that links those two, the variable and the number. So this means another way to write this, you could say 3 times x with a little dot there. Or this could be like 4 times y. Okay? Or you can even rewrite it with parentheses. Sometimes you see that also. 12 and then put the z in parentheses. Okay, 88. Okay, usually the dot, but you could see the parentheses also. But just one small thing we need to realize is when I see a number right next to a variable, we need to realize that means multiplication for the rest of the year and the rest of your mathematics career. That's what that means. So then continuing off that, if I see a problem that says evaluate, again, that means find the value, find the answer. 12p, this expression says, when p equals 8. Okay? Well, this means you're going to put 8 right in there for p. But what I see is a common mistake. Sometimes I see this very often. Okay, I see this problem that when people are going through problems like this, here's what they think to do. They always then say, okay, well, 8 equals p, and then there's a 12 here, so this must mean, well, 12, 8, or 128, or 128, okay? But no, that's not what this means at all. That's why kind of above there I went through. 12 next to p means you're going to multiply. So you could rewrite it just like this, 12 times p. In this case, p is 8, so 12 times 8. Okay, what do I get for an answer there? 96. But that's what that means. When 12 is right next to p, this means multiply. Okay, 2.5x when x equals 10. When you rewrite this, I want you to rewrite then 2.5, and this means times 10. This means multiply. So when I plug 10 in there, that's what it looks like. 2.5 times 10 gives me 25. Okay. This last one, even if you're multiplying by a fraction, okay, 1/2 a when a equals 200. Okay. Well, again, a equals 200. That means I'm going to put 200 right in there. Okay, right in my expression for where a is. So 1/2, and even if it's a fraction right next to a variable, it still means the same thing. I'm going to take 1/2 times 200. What is 1/2 of 200? Well, in this case, that's just 100, so that's how I can figure that one out. 1/2 times 200 just means take half the number. Half of 200 is 100. Okay. And last one on this page, 9m over 8 plus n. Same kind of thing here. I have m equals 8, n equals 4. They give me two different variables that I can put into this expression. That's fine, not too difficult. I can still say, okay, well, m equals 8, so I'm going to put the 8 in for m up here. N equals 4, so I'm going to put the 4 in for n down here. So what happens? I get 9 times 8 on the top, and on the bottom I get 8 plus 4. And then in this problem, I just have to make sure I finish the top first and figure out what that answer is. Finish the bottom, see what that answer is, and then I'm going to divide them at the end. That's what this line in the middle means. So 9 times 8 gives me 72. 8 plus 4 gives me 12, and then when I divide them at the end, I get 6 for my final answer. Again, I've evaluated. I came down to some final value for my answer. One last thing I want to talk about you'll see in this assignment is you'll see powers on this particular assignment. It'll actually say to ask you to evaluate the power. I just want to remind us, I think we've seen these before, but reminder, what is a power? Well, it's a problem. It's actually an expression that looks just like this. So something like 6 to the second power is how we say that. But this bigger number, we actually have names for each of these numbers too when they're in a power. This bigger number we call the base. The base number. and the littler number we call the exponent. Maybe that one sounds a little more familiar, but we actually do have names for each of those numbers in a power. What does it mean when you have like 6 to the second power or some kind of expression like this? Well, this means that I'm going to take the base number and multiply it by itself as many times as the exponent tells me to. So looking down here at this first example, like there is 6 to the second power. Okay, how would you say that? Again, I can say 6 squared also is another way to say that, or 6 to the second power. Two different ways I can say that one. What does this mean? Well, it means that I'm going to take 6 times itself 2 times, right? So if I wrote that as a product, which is what that means, I would say 6 times 6. That's how I would find the answer to this particular problem. 6 squared means 6 times 6, which is just 36. Okay. This next one. How would I say that one? Well, the base is 7, the exponent's 4, so you would say 7 to the 4th power is how that one's said. 7 to the 4th power. What does it mean? It means take the base number and multiply by itself as many times as the exponent tells you to. So it means 7 times itself 4 different times. So 7 times 7 times 7 times 7. If I was going to evaluate it and find the final answer, in this case the answer ends up being 2,401. This third one. Again, how would I say that? The base is 2, the exponent's 9, so it's 2 to the 9th power. And what does that mean? It means take the base number, which is 2, and multiply by itself 9 different times. So this one looks like 2 times 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 2. Okay, 9 different times. And if I evaluate that and actually multiply 2 out that many times to figure out what the answer would be, I end up getting 512. So this is what we're talking about in these kind of problems. What do these mean? Or what does it mean to evaluate a power like this? This is what it's telling you to do. Okay. Last one here. 1 to the 15th, which is kind of a tricky one. That's why I want to put it up on the board. 1 to the 15th, again, is how I would say that. 1 to the 15th power. And how would I write that out? Well, it'd be 1 times itself 15 different times, wouldn't it? 1 times itself 15 different times. I don't even have enough room on the board for that. So, but what would 1 times itself 15 different times be anyway? 1 times 1 times 1 again times 1 again times 1 again. What would that end up equaling? That would end up just equaling, well, 1. Because 1 times 1 is still just 1. If I multiply that by 1 again, I still get 1. Multiply again by 1, I still get 1. So 1 to any power really ends up being just 1 by itself. So one more thing I want to show you about the powers is, again, what those mean, because you'll see those in the assignment also today. And speaking of the assignment, so here's our first assignment of the year. Again, how I'll explain it in class is I will always number my assignments. Every assignment we have in this class will have a number like 1 or 2 or 3 or so on until we get up to 100 and some. So I'm sure we'll have over 100 assignments this year. But so I always start off with, I number them like number 1. This is the first assignment, so 1, and then half a parenthesis. BK, those letters mean that this assignment is in the book. And then dash, well then I'll put the page number. In this case, this first assignment's on page 5. So far this is assignment number 1. It's in the book. It's on page 5, and here are the problems that I want you to do. I want you to do problem number 1, problems 4 through 19, and also problems 22 through 33. And at the end, I always put the date also. And I think the date of this assignment is September 6th.